Dear students, welcome to Mathematics Online classes. In this class, we will discuss CET concepts on increasing and decreasing functions, and also we will solve problems on this. Okay, let me explain the synopsis of increasing and decreasing functions. What is an increasing function? What is an increasing function? See, suppose there is a curve y is equal to f of x, having the curve like this. It is y-axis and y-axis, and it is x-axis. If you draw the curve y is equal to f of x, it is in this shape. Means while moving from left to right, if you are moving up, it is an increasing function. In simple words, we can say. And how will we explain it analytically? Analytically, we will explain it like, let me consider 2 points on the graph. This point is x1, comma y1. y1 in the sense it is f of x1. This first point is f of x1. Let me take the second point is as x2, comma f of x2. What is this x1 and x2? x1 and x2 are x coordinates. X coordinate is nothing but perpendicular distance from y axis. Here you see x1 is less than x2. And what about the f of x1 and f of x2? F of x1 and f of x2 are y coordinates on the curve. Y coordinate of a point is nothing but perpendicular distance from x axis. Okay, here you are observing that f of x1 is less than f of x2. Means for 2 points such that x1 is less than x2, suppose it implies f of x1 is less than f of x2, we say it is an increasing function. And also again in this case we say it as a strictly increasing function. Strictly increasing function means and what is an increasing function? What is the difference? I will tell you later. Now just to observe, it is an increasing function or a decreasing function. Okay, this is about an analytical explanation of an increasing function. How will you explain the increasing function? Using the concept of derivatives. See, at any point on the curve, suppose you write a tangent to the curve. How will be the tangent of that curve? Tangent, slope of tangent to the curve is nothing but dy by dx. Here you are observing dy by dx is equal to positive, because if we extend this tangent, it makes acute angle with a positive direction of x axis. We can consider slope is equal to m is equal to tan theta formula. Tan theta is positive. We can say dy by dx is positive. For increasing functions, slope of tangents at any point will always be a positive value. Next, let me consider a decreasing function. Graph of decreasing functions will be like this. This is y-axis and x-axis. Here you observe, while moving from left to right, are we going down or not? Yes. If we are going down, we say that type of functions as a decreasing functions. If we consider 2 points on it, let me consider here is x1 and here is x2. x1 and x2, what about the corresponding values of y coordinates? This is f of x1 and this is f of x2. Here obviously you are observing x1 is less than x2. x1 is less than x2. x1 is this distance, perpendicular distance from y coordinate, y axis, and also here is x2. x1 is less than x2 here. And what about the f of x1 and f of x2? But here you observe f of x1 is this one, f of x2 is this one. Here you are observing f of x1 is greater than f of x2. Means you can conclude that for x1 less than x2, 2 points on the curve, suppose it implies f of x1 is greater than f of x2, then we can say that type of function as a decreasing function. How will you say with respect to the derivatives concept? With respect to the derivative concept, see, at any point, suppose you write a tangent to the curve. What happens here? Angle made by the tangent with the positive direction of x-axis theta is an acute angle here. So slope of tangent that is dy by dx is equal to tan of an obtuse angle. Tan of an obtuse angle will be a negative value. So dy by dx is equal to negative. Means if dy by dx is negative, then it is a decreasing function. If dy by dx is positive, then it is a increasing function. Okay, this is about increasing and decreasing functions. I will take some of the graphs here just to explain you the conditions and also strictly increasing and strictly decreasing functions. First one, what is the condition for strictly increasing? See, y-axis and x-axis, there is a graph of the function y is equal to f of x. Nowhere on the curve f dash of x is equal to 0. Means if you draw a tangent at any point on the curve, the tangent is not parallel to x-axis. If tangent is parallel to x-axis, what it means? Its slope is 0, because slope of x-axis is 0. Parallel means slope of tangent will be 0. Here f dash of x is not equal to 0 at any case. And then what about this f dash of x values? F dash of x values always greater than 0. Okay. And then what about the strictly decreasing conditions? Y-axis and x-axis graphs will be like this. Suppose it the graph of y is equal to f of x, then here also f dash of x will not be equal to 0 and f dash of x can't be negative also. F dash of x can't be positive. F dash of x is always less than 0 here. This is the condition for strictly decreasing functions. Then what about constant functions? Constant functions are the increasing functions or decreasing functions. Let us take the graph of f of x is equal to some constant like c. Y-axis and x-axis, if you draw the graph, it will be like this. This distance is c. Okay, if you differentiate the function f of x is equal to c, what will be the f dash of x? F dash of x is always 0. If f dash of x is 0 always throughout the domain, then we say that function is a constant function. Here we say this function is neither increasing nor decreasing. This is about strictly increasing, strictly decreasing and also constant functions, the functions which are neither increasing nor decreasing. And then if simply it is given like an increasing function in the sense graph we may consider like this. This is y-axis and x-axis. You observe here, up to this point it is continuously increasing. Here it is a constant function. Means if you take any point here and draw the tangent to that point, here what happens? The tangent will be parallel to x-axis. Here conditions possible are f dash of x is equal to 0 one condition and f dash of x is greater than 0 another one condition. Two conditions are satisfying, So condition for increasing function is f dash of x is greater than or equal to 0. If f dash of x is greater than or equal to 0, then it is increasing function. If f dash of x is always greater than 0, then it is strictly increasing function. Next, what about decreasing function? What is the condition for a decreasing function? Condition for a decreasing function, you can take the graph like this, y-axis and x-axis. Suppose a graph is like this. Here you see, after this point and also from the second point to the last point, if you take tangent at any point, slope of tangent will be less than 0, means f dash of x is less than 0. And if you consider at this point, what about the f dash of x? F dash of x is equal to 0. So what is the condition we will write for decreasing functions? That is, f dash of x is less than or equal to 0. If f dash of x is less than or equal to 0 in that domain, we say the given function is decreasing in that domain. If f dash of x is greater than or equal to 0, we say that the function is increasing function in that considered domain. And what about the strictly increasing function? If f dash of x is greater than 0 in that the defined domain, we say the function is strictly increasing. In the same way, strictly decreasing also in any defined interval like a comma b. In that interval a comma b, if f dash of x is always less than 0, we say the given function is strictly decreasing function. Okay, let me explain with an example. Suppose we have y is equal to x square function. Y is equal to x square function is there. Let us write the graph of y is equal to x square. How will be the graph of y is equal to x square? It is a parabola symmetric with respect to y axis. This is y is equal to x square. Let us take, it is drawn from minus infinity to plus infinity. Here is the point 0. If we consider the interval minus infinity to 0, if we consider the interval from minus infinity to 0, what is happening here? It is continuously decreasing, it is strictly decreasing. This is what? This is strictly decreasing function. And if we consider the interval from 0 to infinity, what is happening here? From the interval 0 to infinity, this function is continuously increasing, means strictly increasing. You can observe from the graph also, strictly increasing. If you want to go with the derivative test, we can do the derivative test also. Let me show that. Here y is equal to x square, dy by dx is equal to what? Dy by dx is equal to 2x. If you take any point in the interval minus infinity to 0, what is happening here? Let us take the point minus 2. Dy by dx at the point x is equal to minus 2 is equal to 2 into minus 2. This is minus 4. We are getting a negative value, we are getting slope as a negative value. And in this interval, if you take any point, it is just for checking, dy by dx at the point x is equal to 3, you take, what happens here? 2 into 3, 2 into 3 equal to 6. It is a positive value, means it is increasing in the interval 0 to infinity. Sir, if you consider the interval from minus infinity to plus infinity, what happens here? If we consider the interval minus infinity to plus infinity, it is up to the 0 it is decreasing, and from 0 to infinity it is increasing. We say here the function is neither increasing, it is neither increasing nor decreasing. Don't say it as it is both increasing and decreasing. That is a meaningless thing. Minus infinity to plus infinity, if this interval if we consider, it is neither increasing nor decreasing, that's all. At the point x is equal to 0, what happens? At the point x is equal to 0, you consider the dy by dx. Dy by dx is 2 into 0. At the point x is equal to 2 into 0, it is nothing but what? 0. 0 in the sense slope of tangent at that point is 0. Slope of tangent at that point is 0. That tangent is parallel to x axis. See, at that point the function is a constant function. Now intervals, instead of considering minus infinity to 0 as open interval, if I consider closed interval, what happens here? Minus infinity to 0, infinity side it should be always open because we don't know what is that infinity. If 0 side it is closed, means this point x is equal to 0 is included in the interval. At this particular point, slope of the tangent is 0. The function is neither increasing nor decreasing. The function is constant at the point x is equal to 0. So here in the interval minus infinity to 0, we are getting f dash of x is less than or equal to 0. Here it is just f dash of x is less than 0 because the point 0 is not included. Okay. In this case, we should say the function is a decreasing function. It is decreasing function. And if we consider the interval 0 to infinity including 0, if 0 is included in this interval, here we have both the conditions. What are those? F dash of x equal to 0 condition and f dash of x greater than 0 condition. Both the conditions are satisfied. At x is equal to 0, f dash of x is equal to 0 condition is satisfied. So here simply we say this function is a increasing function. Don't say it as a strictly increasing function. Okay, this is about considering the intervals, when to consider open interval and when to consider a closed interval. Yes, this is about the concepts and synopsis of increasing and decreasing functions. I have some questions on increasing and decreasing functions. Let us discuss those. First problem. The function f of x is equal to x square plus 2x minus 5 is strictly increasing in the interval. It is strictly increasing in the interval. Okay. Now, let us differentiate. F dash of x is equal to, it is 2x plus 2. 2 into x plus 1. F dash of x is 0. F dash of x is equal to 0 at the point x is equal to minus 1. We can find out using this condition. If we substitute x is equal to minus 1 here, what happens? This f dash of x becomes a 0. If we consider the number line from minus infinity to plus infinity, at the point x is equal to minus 1, there is change in slope of the curve, right? You take the interval 1 to infinity and also minus 1 to infinity and also minus infinity to minus 1 as two intervals. Let us check any point in the interval minus 1 to infinity. What happens? F dash of x is always positive. Let us check x is equal to 2. Like this we can check any point. F dash of 2 is equal to 2 into 2 plus 1. What happens? Is it a positive value or not? Yes, it is a positive. Like that you check any point. Here I can say the f of x is increasing in the interval minus 1 to infinity. And if we check the interval minus infinity to minus 1, you will get f dash of x as negative value. Let us check. Here will be minus 2. At the point x is equal to minus 2, f dash of minus 2 is equal to 2 into minus 2 plus 1. It is what? It is a negative, less than 0. I can conclude that in the interval minus infinity to minus 1, the function is decreasing. They asked you to find out the interval in which the function is strictly increasing. Strictly increasing in the sense, we should not include the point x is equal to minus 1 because at x is equal to minus 1, f dash of x is equal to 0. So, what is the interval? Interval is minus 1 to infinity excluding minus 1. So, which option? Option D is correct here. Now, answering second question. The interval in which the function f of x is equal to x cube minus 6x square plus 9x plus 10 is increasing. Just they said it is increasing. F of x is equal to x cube minus 6x square plus 9x plus 10. Differentiating the function, f dash of x is equal to differentiation of x cube is 3x square minus 6 into differentiation of x square 2x plus differentiation of 9x 9. It is, let me take 3 common here, 3 into x square. If we take 3 common here, for 2 remains, 2 into 2 4 minus 4x plus 3. Okay, this is f dash of x, 3 into x square. It is a quadratic equation. Let me split it as minus 3x minus x plus 3. Now this is equal to 3 into x minus 3 minus 1 into x minus 3. 3 into x minus 1 into x minus 3. Okay, here you can observe f dash of x is equal to 0 at the point x is equal to 1 and 3. Okay, if you draw a number line like this, minus infinity to plus infinity, and there are 2 points at which there is change in slope of the curve, 1 and 3. Let us consider the interval 3 to infinity. 3 to infinity, if you take any value, let me take 4, this is positive, this one is also positive, so f dash of x is positive. If we take the interval 1 to 3, let me take 2 here, 2 minus 1 positive, 2 minus 3 it is negative, it is negative, you know, so function is decreasing in the interval 1 to 3. And also in the interval minus infinity to 1, let us take 0, 0 minus 1 negative, 0 minus 3 negative, so negative into negative positive. Plus means increasing, minus means decreasing. So what is that interval in which the function is increasing, just increasing, it is not strictly increasing and all. So we need to include these points also. Minus infinity to 1, it is increasing in the interval 3 to infinity also, union 3 to infinity. Which option? Option A correct. Next, question number 3. Question number 3 is, for every value of x, the function f of x is equal to e raised to x is, f of x is equal to e raised to x is. Let me find out the derivative of this function. F dash of x is equal to, again it is e raised to x. If we substitute any value of x belongs to real numbers, will it be negative? No, it can't be a negative value, it is always positive only. So will it be will it be 0 and all? There is no question of checking whether f dash of x is 0 or not here, because the options given are decreasing, increasing, neither increasing nor decreasing, and also none of this. And it's for every value of x, the function f of x is equal to e raised to x. It can't be 0, it is definite one, because if you substitute x is equal to 0, what it gives us? It gives us 1, and it may give some 0.00 values also if you substitute the negative values, but it can't give us 0. So what we can conclude here? We can conclude that it is increasing function. F dash of x is greater than 0 here always. This is about a third question. Now answering fourth question. F of x is equal to x. X belongs to the interval minus 1 less than or equal to x less than or equal to 1. Then function f of x is. It is very simple. If you want to go with the derivative test, you can do the derivative test, or else what you do, you draw the graph of it. How will be the graph of f of x is equal to x from minus 1 to plus 1? When x is equal to 0, f of x is equal to 0. When x is equal to 1, f of x is equal to 1. When x is equal to minus 1, f of x is equal to minus 1. Graph goes like this. By seeing the graph itself, you can say the function is an increasing function. If you want to go with the derivative test, you can go with the derivative test also. Here f dash of x is equal to 1. F dash of x is always a positive value, you know. Function is increasing function. Next, fifth question. The function f of x is equal to ax plus b is strictly increasing. For all real x if a condition. What is the condition for a? F of x is equal to ax plus b. Then f dash of x is equal to what? F dash of x is equal to a into differentiation of x is 1 plus differentiation of b is 0. This is a. F dash of x is equal to a. Here this function has to be strictly increasing. For that, what should be the value of a? Value of a, can it be a negative? Strictly increasing, it can't be negative. And can it be equal to 0? If it is simply increasing, it can be equal to 0. It is given that it is strictly increasing. Strictly increasing in the sense a value should be always greater than 0, as we know the concept. So which option? Option A is correct here. Now answering question number 6. The function f of x is equal to 4x square plus 1 by x is decreasing for the interval. In which interval the function is decreasing, we need to check here. Okay, so it is given simply decreasing, not strictly and all, you have to be careful. Let us find the derivative of it. F dash of x is equal to, how we differentiate it? We will differentiate by u by v rule. V kept as it is, denominator kept as it is, differentiation of numerator. Differentiation of numerator 4x square is 4 into 2x plus 0 minus of 4x square plus 1 into differentiation of x is 1 divided by x square. This is 0, 4 into 2x, 8x into x, 8x square. It is minus 4x square minus 1 divided by x square. Nothing but 4x square minus 1 by x square. 4x square minus 1 can be written as 2x whole square minus 1 square by x square. It is like a square minus b square. Write it as a plus b into a minus b. So it is f dash of x is equal to, it is 2x minus 1 into 2x plus 1 divided by x square. So what are the points at which f dash of x is equal to 0? From this point x is equal to minus 1 by 2. From this factor 2x minus 1, it is x is equal to 1 by 2. Minus infinity to plus infinity. And this point x is equal to 0 also. At x is equal to 0, f dash of x is not defined. We should consider that interval also. Okay, it is decreasing. If we take the interval 1 by 2 to infinity, let us check the point x is equal to 1 here. 1 positive, positive, this one is also positive, means it is increasing in the interval 1 by 2 to infinity. Next 0 to 1, or else you check the point minus infinity to, sorry, minus 1 by 2 to plus 1 by 2. You check the point, it is 1 by 2 in the sense it is 0.5. Let me check 0.1 here. 0.1, 2 into 0.1 minus 1, 2 into 0.1, it is nothing but 0.2. 0.2 minus 1 means it is a negative value. Negative into positive. Here it is negative. What about this? This one is also negative. And what about minus infinity to minus 1 by 2? Let us check the point here. Minus 1 will be there. Minus 1. Minus 2 minus 1 negative. Minus 2 plus 1. Again it is negative. So negative into negative positive. This interval again it is positive only. So what is that interval in which the function is decreasing? Negatives you should consider, minus 1 by 2 to plus 1 by 2. Now the case is that whether to put the open interval or closed interval. Simply it is given decreasing, f dash of x can be 0 also. F dash of x is 0 at the points minus 1 by 2 and plus 1 by 2. I have to include that point. Minus 1 by 2 to plus 1 by 2. So which option? Option B is correct. Seventh question. The function f of x is equal to x plus cos x is. F of x is equal to x plus cos x. Differentiating the function with respect to x, this is f dash of x is equal to 1 plus of differentiation of cos x is minus sin x. Now they are asking you, the function is always increasing, always decreasing, whether it is increasing for certain range of x, and none of this. We know that sin x values, if we substitute any value for sin x, because domain of sin x is all real numbers. Domain is all the real numbers. What it gives us? It gives us only in the interval minus 1 to plus 1. It gives us in the interval minus 1 to plus 1, means its range is minus 1 to plus 1. Sin x is giving in the interval minus 1 to plus 1. 1 minus of any value in the interval minus 1 to plus 1. What it gives us? It always gives us a positive value or not? Yes. So we can say here option A is correct. The function f of x is equal to x plus cos x is always increasing. Okay. With this question, we will end our today's class. Thank you.